In this video, I'm going to finish the larger predicate. And the function itself is mostly straightforward, but there's two interesting things that come up here. One is an interesting point about writing tests for functions that consume two of the same type of data. And the other is the pretty fun point where you've built up a whole chain of helpers going from an initial function to a helper to a helper to a helper, and you finally finish that last helper, and bang, 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 bang. If you're lucky, the whole thing works. Okay, now I need to finish the larger predicate, and the examples are what I need to do next. And I'm not going to use the named constants I defined for the last function, and I'll show you why. Let me just get started. Check, expect, larger. It's really easy in a function like this. Here's a function that consumes two images, and it's going to have to get the width and height of both images. And it's really easy in a function like this to make a mistake where, for example, you use the same image twice, or you use the width twice instead of the width and the height. And so what I'm going to do is I'm going to use numbers for my images that are very sensitive to making any one of those mistakes. So watch this. I'll say 3 by 4, solid and red. Oops, I mean rectangle. I was thinking so hard about the numbers I forgot to make the rectangle. Rectangle 3, 4, solid red, and rectangle 2, 6, solid red. Now the area of both of those is the same, it's 12, so that should be false. Now we can make the other 4 cases where we'll vary each of the numbers a little bit. So now let's make this be 5. Now the first rectangle is bigger. We'll make this be 5. First rectangle is also bigger. We'll make this be 5. Second rectangle is definitely bigger. In other words, the first rectangle is definitely not bigger. And for this last one, we'll make 6 be 7. The first rectangle is definitely not bigger. So those are examples. Run to make sure it's well formed. It is. Lots of tests are failing. Now let's see. This is a function operating on 2 primitive atomic data. So we have to make the template for ourselves. The template is define larger question mark img1 img2. And if it was just img2, that would be the template. But we have an additional atomic parameter, so we add img1. There we go. And now what do I need to do? Well, I need to get the area of one of them. So that's the width times the height. And I'll copy here because I was very careful about that. So now I've got the top line is the area of image 1. The bottom line is the area of image 2. And 1 is bigger than 2 if that's a greater than. Command I to fix the indentation. Run. Wow, all at once, only one test is failing. Let's go see which test this is. If I insert I3 into cons I2, I3, oh, this is just wrong. I made this test wrong. This was supposed to be the test where I was inserting I3 into a list that already had I1 and I2. That was just a broken test. If I insert I3 in that list, it should go at the end. Cons I1, cons I2, cons I3. Empty is the result. Now let's run it. All 17 tests pass. So here you're seeing a thing that happens all the time when you start designing more complicated functions and you have to have more and more helpers. Is you get to the end and it kind of all comes together. And if you're lucky, every single test passes. In that one final moment, every single test now passes. you're not usually that lucky. You're almost never that lucky. Usually what happens is you get that final piece done and a bunch of tests start working. But sometimes what happens is there's some tests that are broken, like in this case where there was a broken test. Other times what happens isn't the tests are broken, but that some function along the way actually isn't correct. And then things will only partially work or not work at all. This was a pretty good case. We finished the last function in the chain of helpers, and we had only one broken test that we had to go fix. But whether it all works in one fell swoop or not isn't so much the real issue as much as that now going back to this picture, what happens is all at once, all our boxes get checked off because we finish the helper larger, which basically finishes insert, which basically finishes sort, which basically finishes arrange images. Bang, 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 bang. We check off the whole chain of functions that were waiting on this last helper to be done. So from these lectures for the first part of this week, two main lessons. One is some more helper rules, the rule about function composition, the rule about operating on arbitrary sized data, the rule about a change in knowledge domain. The other is this more macro notion that very often when we design more complicated functions, we end up having to design a bunch of helper functions as we use different helper rules to split the work of the main function out. These rules have an effect similar to the effect that the reference rule has, but in this example, we've seen some additional rules. Whenever you're designing functions, the rest of this course and in the rest of your life, keep these helper rules in mind. They're good guidelines for where to put in a helper function. Some programmers will adopt their own style for using rules in other places, but these are good general principles for where to put helper functions.